All right, so in this case, we are interconverting Kp and Kc. And we can do this. From understanding that pressure is proportional to concentration for gases in a system. So where that comes from is, let's take a look at the ideal gas law equation. PV is equal to nRT. I know that concentration is moles per unit volume, right? So let us change this. If I bring V over, I end up with P is equal to N over V times RT. This is, by definition, concentration. Moles, N represents moles here, per unit volume. And so this tells me that pressure is proportional to concentration. So using the ideal gas law as the basis, the book goes into how you can derive this from this. Okay, so this allows us to convert between Kc and Kp. So what do you need to know in order to do that? You just need to have the chemical reaction equation here so that you can count delta N, the change in moles. Okay, in these formulas, delta N stands for the change in the number of moles, but moles of what? Of gas caused by the reaction. So how do I find change in anything, right? It's final minus initial. So in the context of a reaction, what is your final? Your products. Delta N is equal to moles of products minus moles of reactants. So how many moles of products do I have total? 2. How many moles of reactants do I have total? 3 plus another 1 here is 4. So for this reaction, delta N is minus 2. Okay, minus 2. And you can see how that is. I have 2 moles of product, and then I'm going to subtract from that the total number of moles of reactants, which is 3 plus another one, 4. So 2 minus 4. 2 minus 4 is negative 2. So they say write an equation to show us how to calculate Kp from Kc. So we're going to use this one. Okay, so what is Kp equal to? Kp is equal to Kc, whatever that may be, times R, which is 0.0821, times the absolute temperature, that'll be in Kelvin, and as an absolute temperature, raised to delta N. So delta N in this case was negative 2. And so we have the equation that we need in order to convert from Kc to Kp.